you are going to be expected to perform chemical calculations for amounts of molecules. And these calculations are very, very similar to the type of calculations we do for atoms. For example, if we look at this flow chart, we see that the amounts of molecules can be expressed as one of these three buckets. We can express an amount of a molecule in terms of its mass, in terms of how many moles there are, or in terms of the number of molecules. And we can convert between these different amounts using the two conversion factors of molar mass when we're converting between mass and moles, and Avogadro's number when we're converting between moles and number of molecules. And the calculations are very similar to those that we did for atoms. The only difference is the molar mass of molecules has to be calculated. The molar mass of atoms we can just get on the periodic table, but not the molar mass of molecules. We need the periodic table, but we've got to calculate it. And if you need a reminder of how to calculate the molar mass of a molecule, there's a video on that. So let's look at some examples. A teaspoon of glucose, which is a molecule, has a mass of 4.21 grams. And we're asked to determine how many moles are in the sample and how many molecules. So anytime we do a chemical calculation, we always want to take the time, allow ourselves the time to figure out where am I trying to get to and what am I starting with. And so here, when we look at the information that we're given, we are given mass. So we look at our three buckets, this is where we're starting, and we're going to convert from mass to moles and number of molecules. And the first thing I'm going to do is I'm going to convert between mass and moles because that's the easiest. There's a conversion factor directly between these two of the molar mass of glucose. Once I calculate the moles, then I can easily calculate the number of molecules with Avogadro's number. So it's really super important to take the time to set everything up. Like I said, I like to identify where we're starting from or what we're converting from as the given, and 4.21 grams of glucose is what we're starting with. And then we want moles of glucose in the first part of the problem. So the conversion factor is the molar mass. 1 mole of glucose is equal to 180.156 grams of glucose. And then we take what we're converting from, that's what we begin with, 4.21 grams of glucose, and we multiply it by this conversion factor in ratio form such that the units that we're trying to cancel out, which is grams, go in the denominator. So the 180.156 grams of glucose goes in the denominator and 1 mole of glucose goes in the numerator. And before I do the calculator math, I want to make sure my units cancel out. So grams of glucose divided by grams of glucose cancels out, and I'm left with moles of glucose, which is what I'm solving for. To do the math now in my calculator, I punch 4.21 times 1, which is 4.21, then divide by 180.156, and I'm going to round to 3 sig figs, which is 390 digits after the decimal point, and it's 0.0234 moles of glucose. And that makes sense, because if I have a mole of glucose, I have almost 200 grams of glucose, and 4 grams is way, way, way less than 200 grams. So I should have a small amount of moles, and that's what I see in this problem. So now that we have moles, we can convert to number of molecules using Avogadro's number. And I always like to write everything out, just helps my brain organize the information. We're converting from 0.0234 moles of glucose, and we want molecules. So that conversion factor is Avogadro's number. 1 mole of glucose is equal to 6.022 times 10 to the 23 molecules of glucose. So we start off with what we're converting from, the moles of glucose, and arrange our conversion factor such that the moles of glucose is in the denominator, because that's what we want to cancel out. And then the 6.022 times 10 to the 23 goes in the numerator. I make sure that my units cancel out, my moles of glucose cancel out, and I'm left with units of molecules of glucose, which is what I'm solving for. So I multiply 0.0234 by 6.022 times 10 to the 23. Dividing by 1 doesn't change its value, and I get an answer with 3 sig figs of 1.45 times 10 to the 22. And this makes sense because times 10 to the 22 is an absolutely enormous number, which is what we expect when we're dealing with a measurable amount of a molecule, such as 4.21 grams.